The goal of the ASHRAE Integrated Sustainable Building Design is to design a self-sustaining meteorological station. The idea is to design a building that is able to give the best return on investment after 50 years, and it has to satisfy the ASHRAE standards as well as the owner requirements.
Renewable energy is how we are achieving our net zero goal. The idea is to build a building that generates as much energy as it uses without any carbon being emitted in the process. The overall system that we came up with used solar, wind, it has a connection to the grid, and then we also have it hooked up with a propane generator backup.
The building site is located on a 94-acre island between the southern tip of Chile and Antarctica. So one of the most important things about the building envelope is the foundation. Because the earth is cold there, the more that you increase the insulation value, the more energy savings you see. So after we ran simulations and found out what the best building envelope materials were, we put them all together into a single model, ran the simulation again, and proved a full 30% savings in energy. That 30% savings in energy, even when considering the additional initial cost of the more expensive building materials, will save the owner $725,000 over the life of the building.
So one of the main components of the building is sustainability. One of the things that we looked into was light pollution, the heat island effect of the building, and the recyclables, like the locations where we were going to have recyclable bins in the building. And finally, it was the shading and how that was going to impact the heat island effect.
My responsibility was to meet ASHRAE 189.1 indoor environmental quality, which includes ASHRAE 62.1 on ventilation and ASHRAE 55 with thermal comfort. So the radiant system is a tubing, polyethylene tubing that's inside the slab, where it moves water through the tubing, and since water has a higher coefficient of heat transfer, it uses less energy, and therefore it'll be better for the customer to have a better 50-year lifespan return on investment. So the dedicated outside system, what it does is it brings in 100% outside air, it pumps it into the occupied spaces, and it takes all that air and pushes it back out. So it's recircling outside air from outside and brings it back out.
So for the water use efficiency, we first look at the standards, and then we look at the resources on site to see what we can use to reduce the water consumption even more. By looking at the climate, we noticed that there's a lot of rainfall. So in order to reduce the amount of water used on site even more, we're going to use the rainwater harvesting to reduce our overall water consumption, in addition to WaterSense products and Energy Star appliances. So for our rain harvest water system, we first collect the water and it goes through an initial filter. After that, it gets stored into a cistern. Then the water can be used for gray water for flushing. Now, if you want to do more to those collected rainwater, it would go through another filter, a 5-micron filter to be precise. After that, it would have to go to a UV purifier, and then it can be used for drinking water, it can be used for the cold water supply, to shower, or anything you can think of.
We have put in a lot of hours into this project, and I really have to say, as we're walking away from it, we've put together a good building. This is, aside from all the ticking of the boxes to make sure we hit the codes, this is an energy efficient, sustainable design that would serve these customers well beyond the lifespan that they specify.